Welcome to the Algebra Master Advanced Level DVD. My name is Stephen and I will be presenting this DVD. So what is the purpose of this DVD? The purpose of this DVD is to help you gain a grasp of algebra up to level 10 on the national curriculum. It is aimed specifically at students who are studying algebra at secondary school level who want to gain a complete knowledge of algebra needed at high school level. This DVD contains a series of video tutorials, worked examples and end of unit exercises for you to do. This DVD is not a replacement for lots of hard work and practice. You will need to use this DVD in addition to your normal study program in maths and try as many questions as possible in addition to the ones contained on this guide. It is not a replacement for a complete mathematics course and should be used as a reference guide only. The great thing about this DVD is that each unit is accessible from the main menu and you can pause and rewind the DVD as many times as you like if you don't get things first time. And let's face it, who does? I hope that you'll find this DVD of some use. Should you require any further information, then please visit the Top Maths DVD website. That is www.topmathsdvd.co.uk. Okay, in this section we're going to look at direct and inverse proportion. So when two quantities are in direct proportion, when you double one variable, you double the other variable. So for example, if z is directly proportional to x, we write z alpha x. Now what we do here is we need to replace this alpha with an equals and a k, which represents a constant. So z is equal to kx. So this k is a constant known as the constant of proportionality. So if we were to graph that relationship, z is directly proportional to x, then it would be a straight line graph that goes through the origin. So just to recap, if two quantities are directly proportional to one another, let's say z and x, then we write z alpha x. We replace this alpha sign with an equals k, where k is a constant of proportionality. So when we graph that, it's a straight line which passes through the origin. So when we double the value of x, we double the value of z at the same time. So let's consider a worked example. If y varies as z and y equals 2 when z equals 5, find a, the value of y when z equals 6, and b, the value of z when y equals 5. So just to note that the word varies means directly proportional to, so it's another word which means the same thing, which you'll often see in maths textbooks and also on exam papers. So the first thing we need to do is just to write out this relationship. So y varies as z, so that means y is directly proportional to z. So replace the alpha with an equals and a k. And don't forget to put the z on there. So y is equal to kz. So the first thing we need to do is we need to find the value of k, which is the constant of proportionality. So we find that by substituting in the initial values, y is equal to 2 and z equals 5. So we put 2 is equal to k multiplied by 5. We then divide both sides by 5. So k equals 2/5. Now that we've got the value of k, which is 2/5, we can write out our formula, which is y is equal to 2/5 of z. So using this, we can determine the value of y when z equals 6, which is the answer to part A. So when z is equal to 6, y is equal to 2/5 multiplied by 6. So that means y is equal to 2 and 2/5. Okay, so that's the answer to part A. Part B, we've got the value of y is equal to 5, and we need to find the value of z. So using our formula, y is equal to 2/5 z, so we substitute the value of 5 in there, so 5 is equal to 2/5 of z. So what we need to do, we need to multiply by, both sides by 5, so we get 25 is equal to 2z, and then we divide both sides by 2, so we get 25 over 2 is equal to 2z over 2, so z is equal to 12.5. So the answer is 12.5. Okay, in this section we're going to look at inverse proportion. Now, inverse proportion is the direct opposite of direct proportion. So basically what this means is if you double one variable, you halve the other variable, as opposed to doubling one variable and doubling the other variable. So to illustrate this, consider two variables, s and t. So if s is inversely proportional to t, we write s alpha 1 over t. Of course, we need to replace the alpha with an equals and a constant of proportionality. So we write s is equal to k over t. So if we're going to graph this relationship, then the graph would look like this. So the shape of the curve is similar to that of y equals 1 over x. Okay, so let's do a worked example. So z is inversely proportional to t squared. And z equals 4 when t equals 1. So z is inversely proportional to t squared, and z equals 4 when t equals 1. So z is equal to k over t squared. So what we do is we need to firstly determine the constant of proportionality, which is k. So we substitute the value of 4 into the formula and the value of t, which is equal to 1. So 4 is equal to k over t squared. So 4 is equal to k over 1, so that must mean k is equal to 4. So calculate z when t is equal to 2. Well, z is equal to 4 over t squared, so z is equal to 4 over 2 squared, so z is equal to 4 over 4, so z is equal to 1. Okay, it's time for a quick quiz now. So the first question, y is proportional to t so that y equals kt. If y equals 6 when t equals 4, calculate the value of k and hence find A, the value of y when t equals 6, and B, the value of t when y equals 4. Question number 2, t is inversely proportional to m. If t equals 12 when m equals 1, find A, t when m equals 2, and B, t when m equals 24. If you don't want to know the solution to the quiz, press the pause button on your DVD player now. Okay then, so let's go through the quiz. So let's start off by looking at the answer to the first one. So we're told y is equal to kt, so y is directly proportional to t. So we're told that y is equal to 6 when t is equal to 4. So we need to start off by finding the constant of proportionality. So 6 is equal to k multiplied by 4. So k is equal to 6 over 4. So k equals 1 and 2/4, 1.5. So k is 1.5. So using that, we've got our formula. So y is equal to 1.5 t. So in the next bit, we've got to find out the value of y when t is equal to 6. So y is equal to 1.5 multiplied by 6. So that means y is going to equal 9. So that's the answer to that part. So the next part, we've got to find the value of t when y is equal to 4. So 4 is equal to 1.5 multiplied by t. So we divide both sides by 1.5. So we get t is equal to 2.6 recurring. Okay, so let's go through the next question. So t is inversely proportional to m. So t is equal to k over m, and we're told that t is equal to 12 when m is equal to 1. So that must mean that k is equal to 12. So remember, we must always determine the constant of proportionality first. So we've got to find t when m equals 2. So what we do here, we substitute the value into our formula, which is t is equal to 12 over m. So t is equal to 12 divided by the value of m, which is 2, so t equals 6. So that's the answer to part A. Part B, we've got to find t when m equals 24. So again, t is equal to 12 over m, so we substitute our value of m in there, which is 24, so t is going to equal 12 over 24, so that equals a half. And that's the answer to the second question. Okay, we're going to finish off by looking at algebraic fractions. Okay, so sometimes we're asked to simplify fractions which contain algebraic terms. For example, 3a over 5a squared. So how do we go about simplifying this? Well, the first step is to break it up. When I say break it up, I mean 3a can be broken up into 3 times a, 5a squared can be broken up into 5 times a times a. We simply then cancel algebraic terms. So we match up a set of algebraic terms and cancel. So we're left with 3 over 5a. Let's do another example. 3y plus y squared all over 6y. Now this is a little bit different. We have to factorise on the top first before we can simplify, because on the top here we have a complete algebraic expression which is 3y plus y squared. It's not a standalone term. So if we factorise, we get y brackets 3 plus y on the top all over 6y. Now what we do is simply cancel the y's, so we're left with 3 plus y all over 6. Let's have a look at an example that contains a quadratic. So for example, x squared minus x minus 2 all over x squared plus 4x plus 3. So in this example, what we have to do, again, we have to factorise first. Now you notice we've got a quadratic on the top, so we have to think of two numbers that multiply together to get minus 2 and add together to get minus 1. Well, it's going to be minus 2 and plus 1. At this point it might be a good idea just to expand to test to make sure you get back to what you started with. So just down here, let's just expand that to make sure we get x squared minus x minus 2. So x times x is x squared, x times 1 is x, minus 2 times x minus 2x, and minus 2 times 1 minus 2. So indeed we do get x squared minus x minus 2, so we factorised it correctly. So we now need to factorise the bottom, so we need to think of two numbers that multiply together to get 3 and add together to get 4, so that's just going to be 3 and 1. Again, at this point it's a good idea to expand to test to make sure you get back to what you started with. So again, let's just write that out on the bottom. So x times x is x squared, x times 1 is just x, 3 times x is 3x, and then 3 times 1 is 3. So we end up with x squared plus 4x plus 3. So yeah, we factorised it correctly. Now it's a good idea just to cancel matching factors, so match those up, so we cancel those, and we're left with x minus 2 over x plus 3. So to conclude, when we're simplifying algebraic fractions, it's necessary to either factorise or cancel the terms down in order to simplify it. Okay, so what we're going to do now, we're going to look at multiplying and dividing algebraic fractions. Okay, so let's look at multiplying algebraic fractions then. So let's say we had 3x over 2 multiplied by 2a over 3x. How would we do this? Well, we would solve it just like a normal multiplication of two fractions. So we can cross cancel. So we can cancel these two 3x's. Just put a 1 there. And then just multiply straight across. So we get 2a over 2, and the 2's will cancel, leaving a. Incidentally, you could have cancelled this 2 here with the 2 on the top of the second fraction. You could just cancel that straight away and just been left with a, so that would have been a perfectly good way to do it. So let's do another example. 5mn over 3 multiplied by 2 over n. So again we can cross cancel, so we can cancel this n with this n over here, then multiply straight across. So 5m multiplied by 2, that's going to give 10m. Got a 1 on the bottom here, so 3 times 1, that just gives 3, so we're left with 10m over 3. Let's consider a division now. So let's say we've got 2 over q divided by a over 2. So what we would do here is turn the division into a multiplication, and we would invert the second fraction, that's to say turn it upside down. So we can't cross cancel here, so we multiply straight across. So we get 2 times 2, which is 4, and a times q is aq. So we're left with 4 over aq, which we cannot simplify anymore. Okay, so let's do one more example with division. Let's do something more complicated. Let's do x squared over x squared plus 2x divided by x over x plus 2. So how would you do this? Well, we have to factorise on the bottom of the first fraction on the denominator, so we can do that. So we get x brackets x plus 2, and we turn the division into a multiplication. We invert the second fraction. We can cross cancel, and we can cancel that factor with that over there, so we're left with x over x, which simplifies to 1. Okay, so let's just finish off by doing some examples that involve adding and subtracting algebraic fractions. So for example, let's say I wanted to do 2x over 5 plus 3x over 4. So how would I go about doing this? Well, I'd need to find the lowest common denominator of 5 and 4, the lowest common multiple, so that's obviously going to be 20. 5 goes into 20 4 times that by 4, so that means I've got to times the top by 4 as well, so I get 8x on the top. 4 goes into 25 times, so that means I've got to times the 3x by 5 as well, so I'll put a plus there and put 15x. So I end up with 23x over 20. Okay, so let's do an example now involving subtraction. Let's say I've got 10x over 8 minus 4x over 16. Then we do exactly the same thing, find the lowest common multiple of 8 and 16, which is going to be 16. So 8 into 16 there goes twice, so times the 10x by 2 to get 20x. Put the subtraction there as we're subtracting. 16 to 16, that goes once, so just times the 4x by 1, so it's just the same, 4x. So we get 20x take away 4x, well that's going to be 16x over 16, so the 16s will cancel and I'm left with x. Okay, so it's time for the final quiz then. So you've got to write the following in a simpler form. So the first one, 5ab over 15a plus 10a squared. The second one, x squared minus 3x over x squared minus 2x minus 3. And the third one, x squared plus 4x over 2x squared minus 10x. Okay, so if you don't want to know what the solution to the quiz is, then press the pause button on your DVD player now. Okay, so let's have a look at the solutions then. So the first one, 5ab over 15a plus 10a squared. Well, to solve this we've got to factorise the bottom, so the highest common factor is going to be 5a, so it's 5a brackets 3 plus 2a, and then what we can do, we can cancel the 5 and then the a, so we're left with b over 3 plus 2a. The next one, x squared minus 3x over x squared minus 2x minus 3. Well, that's x brackets x minus 3 on the top. On the bottom we have to think of two numbers that multiply together to get minus 3 and add together to get minus 2. Well, it's going to be minus 3 and plus 1. So the minus 3's, x minus 3's will cancel. So we're left with x over x plus 1. And finally we've got x squared plus 4x all over 2x squared minus 10x. So factorising the top, we get x brackets x plus 4. On the bottom we get 2x brackets x minus 5. So the x's will cancel there, so we're left with x plus 4 all over 2 brackets x minus 5. Okay, in this section we're going to be looking at transformation of curves and functions. So let's start off by looking at what a function is. Well, a function is an operation that is performed on x. A function has three components: an input, which is known as the domain, the process, and the output, which is known as the range. So the input is the values of x that we supply to the function. The process is the procedure that is performed, for example, squares, cubes, add 3, times by 2, etc. And the output, these are the numbers that we obtain from the function after we've performed the process. Some examples of functions are f of x equals x squared, f of x equals x squared plus 3, f of x is equal to 2x plus 4. The notation that we use for functions is f of x. When we graph functions, the f of x value appears on the vertical axis, and on the horizontal axis we have our variable x. So in this example we've got f of x is equal to x squared. So the function of x is to take x and square it. So for example, if we supply a value of 2 into the function, we square it to get 4. So this then forms a coordinate to plot on the graph. So usually what we do is we supply a range of values into the function, and then the corresponding output values we use to then, together with the input values, plot the graph. Okay, so now let's look at the four ways in which any function f of x can be transformed. The first way is f of x plus a. The second way is f brackets x minus a. The third way is a f of x. And the fourth way is f brackets ax. Okay, so let's look at the first way then, f of x plus a. So this has the effect of pushing the graph up the vertical axis a units if the value of a is positive. So to illustrate this, let's consider the graphs here. So the first graph here represents the function here, f of x, which is x squared. Now if we do f of x plus 2, it has the effect of pushing it up the vertical axis 2 units. And the third graph shows the effect of it sliding down the vertical axis 3 units when we do f of x minus 3. So to conclude, f of x plus a has the effect of moving the graph up the vertical axis a units if the value of a is positive, and has the effect of moving the graph down the vertical axis a units if the value of a is negative. Okay, so let's look at the second way in which we can transform a graph. And that is f brackets x minus a. So if we take a look at the first graph, which is f of x, that's the original function, and if we do f brackets x minus 2, then that has the effect of sliding the graph along the x-axis 2 units. If we do f brackets x plus 1, then that has the effect of sliding the graph along the x-axis 1 unit to the left. So just to conclude then, if the value of a is negative, then it will move the graph to the right that many units. So for example, if it's 2, minus 2, then it will move the graph to the right 2 units along the x-axis. If it's a positive value, then it will move the graph to the left that many units. So for example, f brackets x plus 1, so the value of a is plus 1, so it will move the graph along the x-axis to the left 1 unit. Now let's look at the third way in which we can transform a curve, and that is a f of x. So let's just have a look at the first graph here, f of x. And what we're going to do here, we're going to do 2f of x. Now this has the effect of stretching the graph up the vertical axis. So 2f of x will stretch it, will double the maximum height there of the graph. So if you look at the first graph, it reaches a height of 1, whereas on the second graph, if we do 2f of x, it reaches a maximum height there of 2. So effectively what we're doing, we're doubling every single y coordinate. So let's just take a look at another example here. So minus f of x, well, that has the effect of inverting the graph. The minimum point there is minus 1, whereas before it was a maximum point there of 1. Every single y coordinate has been multiplied by minus 1, causing a stretch down the vertical axis. Okay, so we're going to look at the final way in which we can transform a graph, which is f brackets ax. So to illustrate this, let's consider the first graph, which is the original function, f of x. And what we're going to do is do f brackets 2x. Now what this, the effect that this has is it compresses the graph along the x-axis. Technically speaking, it is a stretch, as what we do is we multiply every single x coordinate by the value of 1 over a, and now in this particular case the value of a is 2, which is this value here. So we multiply every single coordinate by 1 over 2, a half in this particular case. So if you look at the original graph, it crosses the x-axis where x is equal to 4, and in the second graph it crosses the x-axis where x is equal to 2. So it's been compressed. So if you look at the third graph, it's actually stretched along the x-axis. Now what's happened here is the value of a is a half, and 1 divided by a half is 2, so we end up doubling every single x coordinate. So instead of crossing at 4, it now crosses where x is equal to 8. So to conclude, when we do f brackets ax, it's a stretch along the x-axis by a factor of 1 over a. So we have to multiply every single x coordinate by 1 over a. We've come to the end of the section now, so it's time for a quick quiz. So let's just have a look at the question then. So we've got the graph of f of x is equal to x squared, and we're asked to sketch the graph of f brackets x minus 2. So if you don't want to know the solution, then press the pause button on your DVD player now. Okay then, so let's have a look at the answer then. So we've got to do f brackets x minus 2. So basically what we have to do, we have to slide the graph to the right along the x-axis 2 units. So it should look something like this. Okay, so now what we're going to do, we're going to look at the laws of indices. So there are 6 basic rules of indices. So the first rule is a to the power n multiplied by a to the power m is equal to a to the power n plus m. So we simply add the powers. The second one, a to the power n divided by a to the power m is equal to a to the power n minus m. And the third one, a to the power n brackets to the power m is equal to a to the power n m. So we simply multiply the 2 powers there. A to the minus n is equal to 1 over a to the power n. And a to the 1 over n is basically the nth root of that. So, and a to the power m over n is basically a to the power of m, and it's the nth root of that. Okay, an important point to note is that anything to the power 0 is always equal to 1. Anything to the power of 0 is always equal to 1, no matter what. So you could have 1,000,000 to the power of 0, 1,000 to the power of 0, it would always equal 1. And anything to the minus 1 is always 1 over that number. So let's do a few worked examples now just to illustrate all of these laws. So let's consider the following. W to the power minus 7 multiplied by w squared. Well, here you simply add up the powers, so minus 7 plus 2 is minus 5, so it's w to the power minus 5. A squared to the power of 4, well, what you do here, you'd multiply the 2 powers together, so you'd get a to the power of 8. Let's do another example. 10y squared divided by 4y. Well, what you do here is you do 10 divided by 4, which is going to be 2.5, and then you do y squared divided by y. Well, when y is on its own, the power is going to be 1, so you subtract those 2 powers, 2 take away 1, 1, so it's just y on its own, so it's 2.5y. Let's have a look at another example. Let's have a look at x to the power 3 over 2. Well, this is simply going to be x cubed, and it's just going to be the square root of that, so it's the square root of x cubed. Okay, so it's time for a quick quiz now. So let's just run through the questions. Simplify the following. The first one, x cubed times by x to the power 4. Second one, b, which is y to the power 6 multiplied by y to the power 7. C, z to the power 50 times z to the power 50. D, x to the minus 3 all to the minus 2. E, 5y cubed multiplied by 2y squared. And F, 6x to the minus 2 divided by 3x squared. Okay, so if you don't want to know what the answers are, press the pause button on your DVD player now. Okay then, so we're just going to run through the solutions to the quiz then. So the first one, we simply add the two powers. So we're going to get x to the power of 7. The second one, y to the power 6 multiplied by y to the power 7. Again, we just simply add the powers. So we're going to get y to the power of 13. The next one, z to the power 50 times z to the power 50, is going to be z to the power of 100. So again, just add the powers. Now this next one, x to the minus 3 all to the minus 2, we simply multiply the two powers. So minus 3 times minus 2 is going to be plus 6. So it's x to the power 6. E is going to be, well, we just multiply the coefficients first. So 5 multiplied by 2 gives 10, and then y cubed times y squared is y to the power of 5. 6x to the minus 2 divided by 3x squared, well, we do 6 divided by 3, which is going to give 2. And then we subtract the power, so minus 2 minus 2 is going to be minus 4, so it's x to the power of minus 4. In this section we're going to be looking at quadratics, which are in the form ax squared plus bx plus c, which of course is equal to 0. There are three main ways to solve a quadratic. They are factorization, by completing the square, and the third method is the quadratic formula. Okay, we're going to start off by looking at factorizing quadratics where the coefficient of x squared is unity, i.e. 1. So let's consider x squared plus 7x plus 12. So to factorize this, we need to think of two numbers that multiply together to get the value of C, and that add together to get the value of B. So what does all this mean? Well, remember that x squared plus 7x plus 12 is in the form of ax squared plus bx plus c. So a is equal to 1, b is equal to 7, and c is equal to 12. So we need to think of two numbers that multiply together to get 12 and add together to get 7. So the two numbers we need are 4 and 3, as 4 times 3 is 12 and 4 plus 3 is 7. Now what we do, we construct two brackets, put x in each bracket with one number in one bracket and the other number in the other bracket. Now it doesn't matter which order you put the numbers in, so you could put the 4 in the second bracket and the 3 in the first bracket, it doesn't really matter. Now a next step which is advisable is to expand the brackets to make sure you get back to what you started with. So just put some arrows in there to indicate the multiplication sequence. So we do x times x, which is x squared, x times 3, which is 3x, 4 times x, which is 4x, and 4 times 3, which is 12. So we end up with x squared plus 7x plus 12. So we know we've factorised it correctly. Now to actually solve the quadratic, we take each factor in turn and equate it to 0. So let's have a look at how we would do that. So let's take the first factor, x plus 4, make that equal to 0, and then just simply solve it like a normal linear equation. So we take 4 from both sides, so x is equal to minus 4, and then take the other bracket, which is x plus 3, make it equal to 0, and then take 3 from both sides. So we have our two solutions then. X is equal to minus 4, or it equals minus 3. Okay, so we're going to do a couple more examples now on how to solve quadratics that are in the form ax squared plus bx plus c, where the coefficient of x squared is unity. So let's have a look at this example. So x squared plus 10x plus 25. So a is equal to 1, b is equal to 10, and c is equal to 25. So we need to think of two numbers that multiply together to get the value of c and add together to get the value of b. So the two numbers we're interested in are 5 and 5. So again, we put two brackets, x in each one number in one bracket, the other number in the other. So again, expand the brackets to make sure you get back to the expression you started with. So x times x is x squared, x times 5 is 5x, 5 times x is 5x, 5 times 5 is 25. So that simplifies to x squared plus 10x plus 25. So we know we've factorised it correctly. Then to solve, just equate each factor to 0 and then solve it just like a normal linear equation. So x equals minus 5. Now as the other factor is also x plus 5, it's a double root. So both the two solutions are x equals minus 5. Okay, so we're going to finish off by looking at one more example. So x squared minus 8x plus 16. So this is a little more tricky. Let's just have a look at the values there. So a is equal to 1 as usual, b is equal to minus 8, and c is equal to 16. So we need to think of two numbers that are going to multiply together to get 16 and add together to get -8. So the two numbers that we're going to need are -4 and -4. Now be careful here, because remember that two negatives will multiply together to get a positive. So -4 times by -4 is equal to +16, and -4 plus -4 is equal to -8. So be very careful with these types of questions. So if you're struggling a little bit with your negative numbers, then I recommend you revise that. So what we do now is construct two brackets, put x in each one, and -4 in one bracket and -4 in another. So expand the brackets. We get x squared minus 4x minus 4x plus 16, which equals x squared minus 8x plus 16. So final step is just to equate to 0. So there we're going to get x equals 4. Again, it's a double root. So I think what I'm going to do now is just do one last example. I know I said I was going to finish on that one, but I just want to do one more example, as the past couple of examples have involved double roots. So I just want to just do one more example just to be on the safe side. So let's have a look at x squared minus x minus 20. So here a is equal to 1, b is equal to -1, and c is equal to -20. So we need to think of two numbers that multiply together to get -20 and add together to get -1. So the two numbers that we're interested in are -5 and 4. -5 and 4, as -5 times by 4 is equal to -20, and -5 plus 4 is -1. So those are the two numbers that we need. So construct two brackets, x in each one number in one bracket, the other number in the other bracket. So expand to test. So we get x squared plus 4x minus 5x minus 20. So that works out as x squared minus x minus 20. So we factorised it correctly. Then take each factor, make it equal to 0, and then solve just like a normal linear equation. So the first root there is x equals 5. Take the second factor, make that equal to 0. So we take 4 from both sides there. So x equals -4. Okay, so that concludes the section on how to factorise a quadratic when the coefficient of x squared is unity. We are now going to look at more difficult factorising where the coefficient of x squared is greater than 1. So for example, 2x squared plus 5x plus 3. How would we factorise this? Well, firstly let's just write out what a, b and c equals. Well, a is equal to 2, b is equal to 5, and c is equal to 3. To factorise this, we need to firstly work out what a times c is. Well, this is just simply going to be 2 multiplied by 3, which is equal to 6. So we need to firstly find two numbers that multiply together to get the value of a times c, which in this case is 6, and add together to get the value of b, which in this case is 5. So the two numbers that we need are 3 and 2, as 3 times 2 is 6 and 3 plus 2 is 5. Now what we do is we split up the 5x and make it the sum of these two numbers. So instead of saying 5x, we say 2x plus 3x. So don't forget to include the x there. It's not strictly just the numbers, it's the algebra as well. So now what we need to do, we need to partition the quadratic, so split it into two, and factorise the left hand side and the right hand side. So factorising the left hand side, we get 2x brackets x plus 1. And factorising the right hand side, we get 3 brackets x plus 1. Now you should notice that there is a repeated factor, which is x plus 1. Now this looks a little bit ugly, so we need to tidy it up a little. So what we do is we put two brackets, and in the right hand bracket we put the repeated factor, and in the first bracket we put the first term outside the first bracket, and in this case we've got a plus 3 here, so we're going to put the second number outside the second bracket being added to this 2x. So to conclude, 2x squared plus 5x plus 3 factorised is 2x plus 3 brackets x plus 1. Now a good idea would be to expand the bracket to make sure we get back to what we started with. So let's just put the arrows in there to indicate the multiplication sequence. So we get 2x squared plus 2x plus 3x plus 3, and that simplifies to 2x squared plus 5x plus 3. So we know we've factorised it correctly. Now to solve, we simply equate each factor to 0, as we did in the previous section. So take the 2x plus 3 and equate it to 0. So we take 3 from both sides there, so 2x equals minus 3, and then we divide both sides by 2. So x is equal to minus 1.5. So that's one factor, and just going to do the next one now. So x plus 1 equals 0, so we take 1 from both sides. So x equals minus 1, or it equals minus 1.5. So that's how you factorise a quadratic when the coefficient of x squared is greater than 1. Okay, I just want to do a few more examples now with how to factorise a quadratic when the coefficient of x squared is greater than 1. So let's just take a look at this example here. 3x squared plus 7x plus 2. So the value of a is equal to 3, the value of b is equal to 7, the value of c is equal to 2. So we need to do a times c, which is 3 times 2 there, which equals 6. So we need to think of two numbers that multiply together to get 6 and add together to get the value of b, which in this case is 7. So the two numbers we need are 6 and 1. So what we do, we split up this 7x and write 6x plus 1x, or just put x and then plus 2. Now you may be wondering where to put the 6x and the x. Do you put the 6x on the right or on the left? Well, the reason I've put the 6x by the 3x squared on the left is simply because there's a common factor there of 3x. It's easy to factorise. So just in case you're wondering where to put the algebra terms. So just going to partition that and factorise the left hand side. So we get 3x brackets x plus 2, and then this on the right hand side cannot be factorised, so it's just x plus 2. So we've got a repeated factor there of x plus 2. So what we do, just put 2 new brackets down here, put that there, 3x. Now there isn't a number outside this x plus 2, so we assume it to be just to be 1. So bring that plus 1 down, and then the repeated factor always goes in the right hand side, on the right hand bracket. So which in this case is x plus 2. Okay, so what we need to do now is just to test it to make sure we get back to what we started with. So we're going to get 3x squared plus 6x plus x plus 2, so that's 3x squared plus 7x plus 2. Okay, so the final step is to equate each factor to 0. So the first one, 3x plus 1 equals 0. So take 1 from both sides. So 3x equals minus 1, then we divide both sides by 3. So x equals minus 1/3. And then the other factor, x plus 2 equals 0, so we take 2 from both sides. So the solution is x equals minus 1/3, or it equals minus 2. Okay, so it's time for another example then. So let's look at 3x squared plus 8x plus 4. A is equal to 3, B is equal to 8, and C is equal to 4. So we need to do A times C, which is 3 times by 4, to give 12. So we need to find two numbers that multiply together to get 12 and add together to get 8. So the two numbers we need are 6 and 2. So we split up the 8x and make it the sum of 6x plus 2x. So we put the 6x on the left hand side of the partition, as there's a common factor of 3x there, and the 2x on the right hand side, as there's a common factor of 2. So factorising the left hand side, we get 3x brackets x plus 2, and on the right hand side we get 2 brackets x plus 2. So we've got a repeated factor there of x plus 2. So in the first bracket we put 3x plus 2, and in the second bracket we put x plus 2, which is the repeated factor. So just in case you're wondering about where we got the two numbers here, it's the 3x is simply the first term outside the first set of brackets, and the 2 is the number outside the second set of brackets. So we need to expand to test. So we do 3x times x is 3x squared, 3x times 2 6x, 2 times x 2x, and 2 times 2 4. So we end up with 3x squared plus 8x plus 4. Okay, so that's been factorised correctly. So now what we need to do is equate each factor to 0. So let's start off with 3x plus 2. So we start off by taking 2 from both sides. So 3x equals minus 2, and then we divide both sides by 3. And we're left with x equals minus 2/3. And then the last one, x plus 2 equals 0, and we take 2 from both sides. So x equals minus 2. So the solution to 3x squared plus 8x plus 4 is x equals minus 2/3, or it equals minus 2. Okay, in this section we're going to look at how to solve quadratic equations by completing the square. So what exactly is completing the square? Well, when you complete the square, you put the quadratic in the form x plus a all squared minus b, and you solve it by equating to 0 and then rearranging the equation in terms of x to solve it. So let's have a look at a worked example. So x squared minus 10x minus 17. So with this quadratic, what we have to do to complete the square is to firstly construct brackets, put x in the bracket, and then you take the value of b, which in this case is minus 10, and you divide by 2 to get minus 5. You then square the bracket, you take the value of minus 5, you square that, which is 25, and then you put take away whatever that value is, all squared, so which in this case is 25. And then you've got a minus 17 there anyway, which we need to put there. And now we need to tidy it up. So minus 25 minus 17 is minus 42. Now to solve it, we equate it to 0, and we first need to get rid of the 42, so we add 42 to both sides of the equation. The next thing we need to do is we need to get rid of this square. So we do that by square rooting both sides. So we get x minus 5 equals the square root of 42. Now we need to put a plus and a minus in front of that because there are two roots. And the next thing we need to do is we need to get rid of the minus 5. So we add 5 to both sides. So there we have our answer. We have x is equal to 5 plus the square root of 42, and also x is equal to 5 take away the square root of 42. Working this out, we get x is equal to 11.48, or x is equal to minus 1.93 to 2 decimal places. Okay, so we're going to look at another example now of how to complete the square on a quadratic equation. So let's have a look at x squared plus 4x plus 1. So we start off by putting a couple of brackets, put x in the bracket, look at the value of b, which is 4, so we divide that by 2 to get 2, put a square, and take away the value here all squared, which is in this case 4, and then we've got a plus 1 here. So simplifying that, we get x plus 2 all squared minus 3, and we equate that to 0. So first thing we need to do is we need to get rid of the minus 3, so we add 3 to both sides. And then we square root both sides. So we get x plus 2 is equal to plus or minus root 3. And then what we do, we take 2 from both sides. So we get x equals minus 2 plus or minus root 3. So working this out, we get x equals minus 0.27, or x is equal to minus 3.73. Both of these values are correct to 2 decimal places. Okay, so we're going to finish off by looking at a more difficult example. So we're going to look at 2x squared minus 8x plus 3. So immediately you will recognise that this is a more difficult example, as it contains a 2x squared instead of just your normal 1x squared. So what we have to do, we have to factorise this quadratic first before we can do anything with it. So we need to take this 2 out and use it as a factor. So we put 2 brackets x squared minus 4x plus 3 over 2. Now what we do, we complete the square to this quadratic inside the brackets. So we create another set of brackets, put x in the bracket, and we look at the minus 4. That divided by 2 is minus 2. So put a bracket and then squared. Minus 2 times minus 2 is plus 4, so then we do take away 4, and then we've got the plus 3 over 2 there. So now what we need to do is tidy it up a little bit. So minus 4 plus 3 over 2 is minus 5 over 2, and we made that all equal to 0. And then what we need to do is we need to divide through by 2. So we're left with x minus 2 all squared minus 5 over 2 equals 0. Then what we do is we add 5 over 2 to both sides. So we get x minus 2 all squared equals 5 over 2. We then square root both sides. So we're left with x minus 2 equals plus or minus root 5 over 2. It's then necessary to add 2 to both sides. So we're left with x is equal to 2 plus or minus the square root of 5 over 2. So x equals 3.58, or 0.42 to 2 decimal places. In this section we're going to look at the quadratic formula. Some quadratics cannot be factorised, and in such circumstances we have to use the quadratic formula. So the quadratic formula is as follows: x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's do a worked example to show how this can be used. Let's say we've got a quadratic 2x squared minus 3x minus 4 equals 0. So the value of a is equal to 2. The value of b is equal to minus 3. And the value of c is equal to minus 4. So what we do now, we substitute it into the formula. So we get x equals minus brackets minus 3 plus or minus minus 3 all squared minus 4 multiplied by 2 multiplied by minus 4 all over 2 brackets 2 times 2 there. So we get 3 plus or minus the square root of 9 plus 32 all over 4. So that basically works out as 3 plus or minus the square root of 41 over 4. So x equals 3 plus or minus 6.403 over 4. So x is equal to 2.35 to 2 decimal places, or it equals minus 0.85. Okay, I'm just going to do one final example now with the quadratic formula. So let's just have a look at this one. 3x squared minus 7x minus 20. So a is equal to 3, b is equal to minus 7, and c is equal to minus 20. So again, what we need to do is just write out the quadratic formula, which is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And what we need to do now is substitute the numbers into the formula, so it's minus 7 plus or minus the square root of minus 7 all squared minus 4 times by 3 times by minus 20 all over 2 lots of 3. So x equals 7 plus or minus the square root of 49 plus 240 all over 6. So x equals 7 plus or minus the square root of 289 all over 6. So x equals 7 plus or minus 17 over 6. So x is equal to 4 or minus 1.6 recurring. Okay, in this section we're going to look at the difference of two squares. So what is the difference of two squares? Well, in mathematics, the difference of two squares is a squared number subtracted from another squared number. Every difference of squares may be factored and represented algebraically. So, what exactly do we mean by this? Well, let's say I've got a squared minus b squared. It can be reduced into two simple brackets as a plus b and a minus b. To prove this, if we expand the brackets, we get a squared minus ab plus ab minus b squared, and these two here cancel out, resulting in a squared minus b squared. So let's do a few more examples involving the difference of two squares. Okay, so you may see questions like factorise y squared minus 16. How would we do this? Well, it's simple really. Just take each term and square root it. So we just take the y squared, we square root that, and that makes y. And we take the 16, just ignore the takeaway there, and we square root that as well to get 4. We then construct two brackets, put the square rooted y squared, which is y, in each bracket, as well as the 4 in each bracket. And then in the first bracket you put a plus, and in the second bracket you put a minus. And just to prove that this works, if we expand it, we get y squared minus 4y plus 4y minus 16. That will cancel out, leaving y squared minus 16. Okay, it's time for another example. So let's have a look at this one here. 4a squared minus b squared. So what we do, we take each one in turn and square root it. So that's going to be equal to 2a, and then b squared, square root of b squared is equal to b. Construct two brackets, put the 2a in each one, as well as the b. And put plus there and a minus there. So we end up with 2a plus b and 2a minus b. And just to prove that that works, we expand it. So we get 2a times 2a is 4a squared. 2a times minus b is minus 2ab. And b times 2a is plus 2ab. And b times minus b is minus b squared. So we end up with 4a squared minus b squared. Okay, and just to finish off, we're going to do a more difficult problem. Let's have a look at a cubed minus ab squared. Well, upon looking at this, we can see that the a cubed can't be square rooted. Neither can the ab squared. So what we have to do, we have to factorise it first. So the highest common factor there is going to be a. And inside the brackets we put a squared minus b squared, as a times a squared is a cubed and a times minus b squared is minus ab squared. So we can apply the difference of two squares rule to these terms inside the bracket. So if we square root a squared, we get a. We square root b squared, we get b. So we need to put a bracket within a bracket and put a in each one, b in each one, plus and then a minus. So the result is a brackets a plus b brackets a minus b, close brackets. Just to prove that this works, we'll expand the brackets. So expanding the inside brackets, just put some arrows in there to indicate the multiplication sequence. So we get a brackets a squared minus ab plus ab minus b squared. So that results in a brackets a squared minus b squared. And then expanding that, we get a cubed minus ab squared. Okay, so it's time for a quiz now. So let's have a look at the questions. So the first one in part A is factorise x squared minus 6x plus 8. The second one is factorise 3x squared minus 5x minus 2. The third one, factorise 9x squared minus 16y squared. Part B is use the quadratic formula to solve. The first one is x squared plus 5x minus 14 equals 0, and the second one is 2x squared plus 7x minus 15. Okay, so if you don't want to know the answers to the quiz, then press the pause button on your DVD player now. Okay, so let's go through the solutions to the quiz. So the first one, x squared minus 6x plus 8. Well, we need to think of two numbers that multiply together to get 8 and add together to get minus 6. So the two numbers we need are minus 4 and minus 2. So put two brackets, minus 4 in one bracket and minus 2 in the other. So a good idea to expand test to make sure we get back to what we started with. So that makes x squared minus 2x minus 4x plus 8. So there we have it. Now the question doesn't ask us to solve it, it asks us to factorise it. So we don't need to take it any further than that. So let's look at the next one. 3x squared minus 5x minus 2. Well, here a is equal to 3, b is equal to minus 5 and c is equal to minus 2. Now we have to use the second method to factorise because the coefficient of x squared is greater than 1. So we do a times c, so that's equal to 3 times minus 2, so that's minus 6. So we need to think of two numbers that multiply together to get minus 6 and add together to get minus 5, the value of b. So that's just going to be minus 6 and 1. So what we do, we split up the minus 5x and make it the sum of minus 6x and x. Then what we need to do, we need to partition it, factorise each side. So the highest common factor here is 3x. So it's 3x brackets x minus 2. And then we've got plus x minus 2 here. So we've got a repeated factor. Incidentally, just in case you're wondering, we put the minus 6 to the left of the partition because there's a common factor there of 3x. It wouldn't work if you put the x, this x here over the left hand side of the partition. So what we do now is put two brackets. The repeated factor goes in the right hand bracket. This first term here goes here, and although there's no number here, that's basically 1, so this plus 1 here will go here. So we've got the expression factorised now, so let's just expand to test. So we get 3x squared minus 6x plus x minus 2, so that makes 3x squared minus 5x minus 2, so we've factorised it correctly. Okay, let's have a look at the third question in part A, factorising 9x squared minus 16y squared. Well, if we take 9x squared and we square root it, we get 3x, and if we take 16y squared and square root that, we get 4y. So in the first bracket it's 3x plus 4y, and in the second bracket it's 3x minus 4y. So just to expand to test, we get 9x squared minus 12xy plus 12xy minus 16y squared. That will cancel out the minus 12xy and the plus 12xy, so we're left with 9x squared minus 16y squared. Okay, so just going to have a look at the solution now to section B part A, using the quadratic formula to solve x squared plus 5x minus 14. So we start off by stating the quadratic formula, we substitute in, so replace b with 5, replace a with 1 and c with minus 14, and eventually we end up with x is equal to minus 5 plus or minus the square root of 81, the square root of 81 being 9, that's all over 2, so x is minus 5 plus or minus 9 divided by 2, so x will equal 2 or it will equal minus 7. Okay, and we're just going to go over the final quadratic formula question. So 2x squared plus 7x minus 15 equals 0. So we state what a, b and c are equal to. So a is equal to 2, b is equal to 7 and c is equal to minus 15. We write out the quadratic formula, we substitute in, replacing b with 7, a with 2 and c with minus 15. So we arrive at x is equal to minus 7 plus or minus the square root of 169 over 4, the square root of 169 being 13. So x is equal to minus 7 plus or minus 13 over 4, so x will equal 1.5 or it will equal minus 5. Okay, in this section we're going to look at simultaneous equations. So just to recap, a simultaneous equation is an equation that contains two unknowns, usually x and y. So for example, 2x plus 5y equals 24 and 4x plus 3y equals 20 is an example of a simultaneous equation. So how do we go about solving this simultaneous equation? Well, firstly, let's just label the equations 1 and 2 just to make it a little bit more clear as to what we're referring to. We need to just look at these operators here, and if they're both the same, which in this case they are, then we need to subtract equation 2 from equation 1. If they are different, then we need to add them, but we're going to look at an example involving that later on. So the whole idea of either subtracting the two equations or adding them is that we eliminate one of the unknowns, either x or y. Well, if we look at this, if we do equation 2 subtract equation 1, then we don't eliminate any of the unknowns, because 2x take away 4x is going to give minus 2x, and 5y take away 3y is going to give 2y. So when we take equation 2 away from equation 1, we don't eliminate one of the unknowns. So what we have to do is we have to multiply one of the equations or both of the equations such that we have the same amount of x's on the top as we have on the bottom, or the same amount of y's on the top as we have on the bottom. So if we just look at equation 1, if I times all of that by 2, I'll end up with a 4x on the top. So when I do 4x take away 4x, it will eliminate, and you'll see what I mean in a little while. So let's just multiply the top equation, equation 1, all by 2. So by doing so, I'm going to end up with a brand new equation. So on the top I'll have 4x, as 2x times 2 is 4x, 5y times 2, that's going to give 10y, and 24 multiplied by 2 is going to give 48. So I'm going to call that equation 3 as it's a new equation. I'm not going to do anything with equation 2, so I'll just rewrite that underneath. And again, just label it. I'm just going to put a line underneath that. So 4x take away 4x, that's just going to give nothing. 10y take away 3y, well, that's going to give 7y. And 48 take away 20, well, that's going to give 28. So I've got 7y equals 28. So what I need to do, I need to get rid of this 7 here. So I divide both sides by 7. So that cancels out like so. So 28 divided by 7 is 4. So y equals 4. So I've solved half of it already. So what I need to do now, I need to sub in y equals 4 into one of the equations. So I'm going to sub it into equation 1. So instead of putting y, I'm going to put 4. So 2x plus 20 equals 24. So I've got a linear equation here. So firstly, I'm just going to take 20 from both sides. So 2x is equal to 4, and then I'm going to divide both sides by 2. So I get x equals 2. So I've solved the simultaneous equation. I can do a little check. just to make sure I've got the right answers by substituting in x equals 2 and y equals 4 into one of the equations. So I'm just going to substitute it into equation 2. So 4 brackets 2 plus 3 brackets 4, so I get 8 plus 12 there, which equals 20. So I've solved that correctly, and that's how you solve a simultaneous equation. Okay, so we're going to look at another example of a simultaneous equation. So let's consider 3x plus 2y equals 11 and 2x minus y equals minus 3. So the first thing we need to do is label the equations 1 and 2. We're going to look at the operators. Now they're both different, so we have to add the two equations together. So before we write anything, we need to do a little check. So when we add the two equations 1 and 2, do we eliminate one of the unknowns? Well, if we do 3x plus 2x, we get 5x, and 2y add minus y, well, that's just going to give y. So we don't eliminate one of the unknowns. So in this particular case, we have to make sure that we have the same amount of y's on the top as we have on the bottom. So we need to multiply equation 2 by 2. So we get 3x plus 2y equals 11 on the top, and 4x minus 2y equals minus 6 on the bottom. So we've got a brand new equation. So if we add the two equations together, we get 7x equals 5. So 7x equals 5. So now what we need to do, we need to find out the value of x. So we've got a linear equation here, so we simply divide both sides by 7. So we've got our answer there for x, so it equals 5/7. So now what we need to do, we need to substitute x equals 5/7 into one of the equations. So for example, equation 1. So we sub in x equals 5/7 into equation 1. So you got 3 brackets 5/7 plus 2y equals 11 there. So 3 multiplied by 5/7, that's 2 and 1/7 plus 2y equals 11. So now what we need to do, we need to take 2 and 1/7 away from both sides. So we're left with 2y equals 8 and 6/7. Okay, and then what we need to do, we need to divide both sides by 2. So we get y is equal to 4 and 3/7. So x is 5/7 and y is equal to 4 and 3/7. So what we need to do, we need to do a check. So we need to sub in x is equal to 5/7 and y is equal to 4 and 3/7. Let's say we'll put it into equation 2 just to make sure we get the correct answer. So we do 2 lots of 5/7, take away 4 and 3/7. So does that give us the right answer? Well, 2 times 5/7, that's 1 and 3/7. So we need to do 1 and 3/7 minus 4 and 3/7. So that's going to give us minus 3. So yes, we have got the correct answer. Okay, so we're going to finish off by looking at one last example. So 5x plus 2y equals 13 and 2x plus 6y equals 26. So first thing to do, label the equations 1 and 2. Next thing to do, look at the operators. They're both the same, so that means we have to perform a subtraction. So we need to check to see if we can eliminate one of the unknowns when we subtract. So 5x take away 2x, that's going to give us 3x. And 2y take away 6y, that's going to give us minus 4y. So we need to multiply the top equation by 3. So we've got the same amount of y's. So times that by 3 there. So multiply everything by 3, so we're going to get 15x plus 6y equals 39, and that's equation 3. And then we've got 2x plus 6y equals 26 on the bottom, that's equation 2. So 15x take away 2x, that's 13x. 6y take away 6y is nothing. 39 take away 26, that's 13. So 13x equals 13. So that means obviously x is going to equal 1. So we sub in x equals 1 into equation 1. So we get 5 brackets 1 plus 2y equals 13. 5 plus 2y equals 13. So we take 5 from both sides. So we end up with 2y equals 8. And then divide both sides by 2. So y is equal to 4. So we need to do a quick check. So we sub in x equals 1 and y equals 4 into 2. So you get 2 lots of 1 plus 6 lots of 4, so it's 2 plus 24 equals 26. And there you go. So that's how we solve that equation. Okay, so we're going to do a quiz now. So solve the following simultaneous equation. Three a minus b equals 9. 2a plus 2b equals 14. So if you don't want to know what the answer is, press the pause button on your DVD player now. Okay, so let's go through the solution. So the first thing we need to do is label the equation 1 and 2 respectively. Just looking at the operators here, we've got a minus and a plus, so they're different, so that means we have to add the simultaneous equations together. So we have to make sure we have the same amount of b's on the top as we have on the bottom, as we've got minus b on the top and a plus 2b on the bottom. So if we have the same amount, then when we add the two together it will eliminate. So if I multiply the top equation by 2, we get 6a minus 2b equals 18, and on the bottom 2a plus 2b equals 14, so that doesn't change, so that's just equation 2, and we've got our brand new equation here which I'll put as equation 3. So what we need to do now, we need to add the two equations together, so we get 8a on the top, the b's eliminate, and we get 32, as 18 plus 14 is 32, so we divide both sides by 8. So dividing both sides by 8, we get a is equal to 4. Now what we need to do, we need to sub in a equals 4 into the first equation. So we put 3 brackets 4 minus b equals 9. So that's 12 minus b equals 9. Now by inspection you can quite clearly see that b must equal 3. So we've got our two answers. So what we need to do now, we need to do a quick check. So we substitute our values into one of the equations that we haven't already substituted into. So we sub in a equals 4 and b equals 3 into, we'll put it into the second equation. So we've got 2 lots of 4 plus 2 lots of 3. So that's 8 plus 6, which equals 14. So we've got the correct answers there for our simultaneous equation.